Lesson 7.1a, Graphing Standard Form. So graphing a parabola from standard form of y equals ax squared plus bx plus c, you're going to need three things: your vertex, the axis of symmetry, and the direction of the opening. Alright, so for example number one, we have y equals x squared plus 2x plus 2. And let's begin by finding the axis of symmetry. If you remember from standard form, we have variables here of a, b, and c, and these are corresponding to the coefficients of this given. There is a 1 in front of this x squared, so we can identify a, b, and c. A is equal to 1, b is equal to 2, and c is equal to 2. Now our formula for the axis of symmetry is going to be x equals negative b over 2a. So we can plug in a and b. To do that, we get x equals negative 2 over 2 times 1, which simplifying this ends up being just negative 1. Okay, so my axis of symmetry is going to be at negative 1. Let's sketch that on the graph. Now the axis of symmetry for this x value is also part of my vertex. So my vertex is defined as the following. We have x and y. And this x here, the axis of symmetry, is going to be corresponding to the same one as well. So in order to find the y value, we need to plug in this x value into this original problem. And if we do that, we have y equals 1 negative 1 squared plus 2 times 1 negative 1 plus 2. Squaring this gives me positive 1, and then 2 times negative 1 is minus 2, and then plus 2. Alright, these two cancel out, so the matching y value is going to be equal to 1. Alright, so my vertex is located at negative 1, positive 1. So this point is located at negative 1, positive 1, which is right here. And in order to generate a nice curve, we'll need to graph 2 more points. So to the right of this negative 1, we'll plot x equals 0 and get a matching y value, and then x equals 1 and get a matching y value. So for x equals 0, we can plug in 0 into this equation. So y equals 0 squared plus 2 times 0 plus 2. 0 squared is 0, 2 times 0 is 0, and then plus 2. So the matching y value for this is going to be 2. This point is 0, 2, also known as your y-intercept. Okay, so 0 and 2 is located right here. And because we have an axis of symmetry, we can just reflect this about this x equals negative 1 and get the other point across. Alright, one more point, and this one's going to be for x equals 1. If we plug that in, we get y equals 1 squared plus 2 times 1 plus 2. 1 squared is equal to 1 plus 2 times 1 is 2 plus 2. So this y ends up being 5. And this point is located at 1, 5. And that's going to be right here. And same thing, we can reflect this across, and that's going to be right there. All right. So here's the curve for this function. Now you just have to generate a nice curve through them, parabola, and it should look like this. All right, one thing I forgot to mention was the direction of opening, and you can tell whether this is gonna go up or down based on A, okay? If A is positive, it's gonna open up. If A is negative, it's gonna open down. So keep that in mind when you're graphing this. Example number 2. So we'll identify A, B, and C first. A in this case is equal to 2, B is equal to 12, and C is equal to 17. All right, so the first step was to find the axis of symmetry. And we can do that. We'll just have to plug in A and B. All right, because A is 2 in this case, and it's positive, this is going to end up opening up, okay? So it's going to look something like that, with the arrows facing upward. So x equals negative b over 2a. B is 12 in this case, and a is 2, so 2 times 2. Simplifying this, we get negative 12 over 4, which is going to be equal to negative 3. Okay, so the first point in the vertex is going to be equal to negative 3. To find the matching y value, let's take negative 3 and plug it into the original problem. So y equals 2 times negative 3. I always like to use parentheses whenever I plug in numbers, because most of the times I end up multiplying, and the parentheses says to multiply. So negative 3 squared plus 12 times negative 3 plus 17. All right, so following the order of operations, I need to do exponents first in this case. Negative 3 times negative 3 becomes positive 9. Okay? And then positive 12 times negative 3 is going to become negative 36. And 17 is at the end here. Multiplying these two, we get 2 times 9 is equal to 18 minus 36 plus 17. And then adding all these together, I have 18 here and 17 here. And that's going to be equal to 35. So 35 minus 36. And then I do end up with y equals negative 1. So the matching y value for the vertex is going to be negative 1. Okay? So I can sketch the axis of symmetry. That one's at negative 3. Right here. And the vertex is going to be at negative 3, negative 1. So negative 3, negative 1. Right here. All right. Now let's just evaluate at 2 different points. And let's go to the right, because they get lower as we approach 0. And it's going to make our calculations easier. So let's say for x equals negative 1 in this case, or negative 2. We'll plug in negative 2 in. So y equals 2 times negative 2 squared plus 12 times negative 2 plus 17. And multiplying out the exponents again first, negative 2 squared, it becomes 4. 12 times negative 2 is negative 24. And 17, multiplying out 2 and 4, that becomes 8. Minus 24 plus 17. And adding these together, we get 8 and 17 become 25, and 25 minus 24 is positive 1. So y equals positive 1. So the matching y value for this set is going to be -2, comma, positive 1. And that's located here at -2, positive 1. Okay? So now that you have 2 points, you can reflect this one that you just found. And now we can see that a equaling 2 does open the parabola upwards. Okay, one last point. In order to generate a nice curve, we'll evaluate at x equals -1. So for x equals -1, let's plug it in. We have y equals 2 times -1 squared plus 12 times -1 plus 17. -1 squared becomes just 1. And 12 times -1 becomes -12 plus 17. 2 times 1 is 2 minus 12 plus 17. And we add, that becomes 10. 2 minus 12 becomes -10. And -10 plus 17 becomes +7. All right, so the matching y value here, I guess y equals +7. That's going to be -1, comma, +7. And that point is located here, -1, and then up 7, right here. So not only does the graph open upwards, but it's a lot narrower than our usual parent function. Right? And that's because of a equals 2. So that's how this parabola looks like.